Hello and welcome to MyScience Tutorials. In today's video, we are going to be looking at Hooke's law and Young's modulus. And then under Hooke's law, we'll be looking at what elasticity is, and then the relationship between elasticity and then an extension in an elastic material. Then under Young's modulus, we are going to be looking at tensile strain and then stress. Then we'll look at the relationship between the tensile strain and then the strain, the stress and then the strain, and then how to use this relationship to solve some practical examples. So let's get started. So before we get started, we want to look at what an elasticity is. So what is elasticity? Well, elasticity is the ability of a substance or material to regain its original shape and size after it has undergone deformation. So assuming we have let's say a spring here, okay, then after we applied a certain force, so we pull the string, and then the string has now extended up to this side. So we can see from here to here is the new is the extension, that is the added length that we got when we added when we applied a particular force. So from where the spring is at the original position and to the final length is the extension. Okay, so if this spring, okay, is able to come back to this length after we remove the force, then this spring is said to be what, or is said to have what, an elastic ability. Okay, so that is what elasticity simply deals with. It deals with the ability of a material to regain its original shape after it has undergone a deformation or a force has been applied, and then the material regain its original shape and size. Now, the relationship between the force that is applied to cause the extension in an elastic material is described by the Hooke's law. Okay, so Hooke's law tends to explain the relationship between the force and then the extension in an elastic material. So according to Hooke's law, it said provided the elastic limit is not exceeded, okay, that is the elastic limit of this spring, for example, provided it is not exceeded, then the extension in the elastic material is proportional to the force. So what does this mean mathematically? So mathematically, okay, so mathematically it means what, the force in an elastic material is proportional to the extension in the material. Now we know that whenever we remove a proportionality sign, we tend to introduce a constant. So we have our force to be equal to what, Ke, and then the K is our what, constant of proportionality, which in this case is what we call the spring constant. Spring constant. Okay, and then it has the unit of what, Newton per meter, or Nm inverse. So this is the unit of what, the spring constant, because if you make K the subject over here, we have it to be equal to what, force divided by the extension, and then the force is measured in newtons and then the extension is in meters. So that is how come we are having this as the unit. So the relationship between the extension in an elastic material and then the force applied to cause the extension is described by the Hooke's law. Now, with that being dealt with, let's have a look at what Young's modulus also is, and then how we can use both Hooke's law and then Young's modulus in solving some practical examples. So before we look at what Young's modulus is, let's have a look at something we call tensile stress and strain. Tensile stress and strain. Now, for a tensile stress, okay, this is simply what, the force per unit area. So we have force divided by area. So this is what tensile stress is. It's just the force applied over a particular area, okay, and it has the unit Newton per meters squared. Okay, so the tensile strain, on the other hand, the strain is just what, the extension per unit length. So you have the extension in an elastic material per the length of the original length of the elastic material. Okay, and then this is dimensionless. It has no unit, okay, because the extension is in meters, and then the length is also in meters, so they both cancel out, and then this has no unit. Now, a new modified version of the Hooke's law in Young's modulus is what it states that provided the elastic limit is not exceeded, okay, the stress, okay, the tensile stress over here is proportional to the strain. Okay, that is, according to Hooke's law again, what stress is proportional to strain. Okay, it's proportional to strain. Okay, and in this case, when we remove the proportionality sign, it means the stress is equal to what? A constant E times strain. And then the constant E over here is what we are calling the Young's modulus of elasticity. Okay, so simply the Young's modulus E over here, if we make E the subject from here, we can see we will have stress on what? Strain. So Young's modulus is simply the ratio of what? The tensile stress to the tensile strain of an elastic material. That is what Young's modulus is. Now from here we can see that the stress is what we said is force over area here. So we have force divided by area. Let me divide this side. Okay, so we have the Young's modulus to be what? Force over area divided by the strain, which is the extension per unit length. Okay, so if we simplify this and we try to make force the subject, we will be having the force to be what? The Young's modulus times the area times the extension over the unit length of the elastic material. So this is the relationship between force and then the Young's modulus of an elastic material. Now with this basic introduction to what Hooke's law is, and then how the relationship between force and then the extension in an elastic material is, let's have a look at some practical examples to actually understand all that we've been doing so far, or we've been talking about so far. So let's have a look at example number 1. So example number 1, it says that a body of mass 2 kg is attached to the end of a vertical wire of length 2 meters and diameter 0.64 millimeters, and the extension is what? 0.6 millimeter. Find I, the tensile strain, stress. Sorry, one is supposed to be stress, and then the other one is supposed to be strain. So the second one is the strain. Sorry about this. This is the strain. So we are to find the tensile stress, the II tensile strain, and then the III Young's modulus, given that the gravity over here is what? 9.8 meters per second square. So let's see how we can solve this. So we have here solution. So let's have a look at the parameters we are having over here. So we have a body of mass 2 kilograms. So we have mass to be what? 2 kilograms. It's attached to the end of a vertical wire of length. So we have length, okay, to be what? 2 meters. And then a diameter, we have the diameter of the wire to be what? 0.64 millimeters. 0.64 millimeters. And then the extension is what? 0.60 millimeters. Okay, and then we have been given gravity over here. So now let's look at what the question is asking us to find. So the first part, we are to find what? The tensile stress. So I'm just going to write stress over here. Okay, and then we know that the stress is what? Force over what? Area. Okay, so which means the force is what? Mass times what? Gravity divided by, now the area in this case, because we don't have any length and we don't have breadth, okay, in this example we'll be using what? The formula what? Pi d squared divided by 4 as the formula for the area. So our area here is what? Pi d squared divided by 4. So in place of the area over here, we'll be substituting pi d squared over 4 over there. So we have what? pi d square divided by 4 as that of the area. So if we input our parameters in here, we have our mass is what, 2 kilograms, then our gravity is 9.8 divided by pi. The diameter over here is what, 0.64 millimeters, so times 10 raised to the power minus 3 squared divided by what, 4. Okay, and this is supposed to be the bigger division. So if we input everything we have over here, the top will give us what, that's 19.6 divided by the bottom, everything over here will give us what, 3.22 times 10 raised to the power minus 7, 3.22. okay, so we have over here our final answer for this is what, 6.0808 times 10 raised to the power minus 7 Newton per meters square. Okay, so this is our tensile stress, the stress that we have in this particular example. Now let's have a look at the second part, the II, which is the strain. Okay, and then the strain we know is what, the extension per what, the unit length. Okay, and then the extension we have over here is what, 0.60 times 10 raised to the power minus 3 divided by the unit length we have is 2. So our strain in this example is what, 3.0 times 10 raised to the power minus 4, and it has no unit, so this is dimensionless. Alright, so with this we can finally calculate the Young's modulus, which is the third part of this. So the Young's modulus, which is given by E, okay, the formula is what, our stress on what, strain. And then luckily enough for us, we've been asked to find the stress and then the strain differently, so all we need to do is what, divide the strain by the stress. So we have 6.08 times 10 raised to the power minus 7 divided by what, 3.0 times 10 raised to the power minus 4. Okay, so if we input everything we have over here into the calculator, we will be getting 2.03 times 10 raised to the power minus is positive 11, not minus 11. So yeah, so we'll be having 2.03 times 10 raised to the power positive 11, and then our unit will still be what, Newton per meters square. So this is how we solve an example on Young's modulus and then Hooke's law. Okay, so this is an example number 1. Let's look at another example. So example number 2. So we have a spring of natural length 3 meters is extended by what, 0.01 meters by a force of what, 4 newtons. What will be its length when the applied force is 12 newton? Now this is a little bit tricky of a question, so we need to digest everything well. So first of all, let's write our solution. We have here a spring of natural length, so we have L1, the first length is what, 3 meters, and then is extended by what, so the extension we have in the first scenario is what, 0.01 meters. Okay, and then the force that is causing the extension is what, 4 newtons. Now the question is telling us what will be the new length, okay, or its length. Okay, so L2 we don't know when the applied force, okay, is what, 12 newtons. So they are telling us when the force was 4, the extension was 0.01, and then the length was 3 meters. So what is the length if the force is now 12? Now one thing we need to take note of is that the constant of proportionality, that is the spring constant K, if it is for the same material, it doesn't change whether the force applied is big or is small, because it's a constant, it remains the same. So the value of K is the same irrespective of whether the force applied is big or small. So what we need to do in this example is to first use the first parameters we have over here to find the constant, and then use the constant to find the extension in the second case, and then we add that extension to the length, the initial length. So what do I mean by this? So we know that per Hooke's law, force is proportional to what? The spring constant times the extension. So we have the force in the first case is 4 newtons, is equal to the spring constant is K times the extension, which is what? 0.01. Okay, so our K is equal to what? 4 divided by 0.01. So our spring constant in the first scenario is what? 400 Newton per meter. Okay, so because our spring constant is this, we can use that in the second scenario. Okay, so it means in the second scenario we will have this is F1, so let me denote this as F1, this is F2, this is also F2. So in the second case we have KE, but then we have our second force to be what? 12 is equal to, now the spring constant is what? 400 times the extension. Extension is what we don't know, so we find the extension in the second case. The extension in the second case is what? 12 divided by 400. So the extension is what? 12 divided by 400 will give us what? 0.03 meters, which means when the force applied was 12 Newton, the extension in the material was what? 0.03. So the length L2 over here, L2 will be simply what? L1 plus the extension. Let me make this E2. Okay, so the new length, which is the L2 that we are supposed to find, is what? 3 meters plus the extension, which is what? 0.03 meters, and then the L2 is now what? 3.03 meters. Okay, so this is how we solve questions based on Hooke's law and then using Young's modulus. So thank you guys so much for watching, and then if you are new to my science tutorial, kindly consider subscribing by pressing the red subscribe button, okay, to get notified whenever we upload a video. So thank you so much for watching, and I'll see you in the next video. Bye bye.